Hey guys, in this video we're going to take a look at the measures of center that are discussed in section 3.2. We'll try to work through a couple of problems that involve these measures of center that we're taking a look at. First one we're going to look at is the mean, sometimes referred to as the average, although they do say in this book, they caution you not to use average because sometimes average is used incorrectly. Some people call the median or the mode the average. The mean is actually what people are supposed to mean when they say average, so they are sort of the same thing. The mean is of a set of data is the measure of center that's found by adding the data values and dividing the total by the number of data values. That's your definition right here. We've got a couple of important properties of the mean. The sample means are drawn from the same population, tend to vary less than other measures of center, and the mean of the data set uses every single data value. A disadvantage of the mean is that just one extreme value, or outlier, can change the value of the mean substantially. Since the mean cannot resist substantial changes caused by extreme values, we say that the mean is not a resistant measure of center. Some of the other measures are resistant to the outliers, but this one is not, because an outlier can make a significant change in the value of the mean. All right, let's drop down and take a look at this. This is how we calculate and the notation that's used when we're dealing with the mean. Mean is typically represented by x bar if it's the sample mean. From a population, we use the lowercase Greek letter mu, and you can see that right here too. Okay, it's written there in that little green box. The mean of a sample is equal to the sum of all the data values divided by the number of data values. N right here is your sample size. So if we drew 10 data values from a population and we took the mean of those values, then our N value would be 10 down here at the bottom. Okay? So let's take a look at an example just of finding the mean. If we scoot down here to example 1, Table 3.1 includes counts of chocolate chips and different cookies. Find the mean of the first 5 counts for Chips Ahoy regular cookies. And I'm sorry, this kind of cut it off a little bit, but those values are 22, 22, 26, 24, and 23. So we're going to add all of those values up together. And then we're going to divide that by the number of numbers, which is 1, 2, 3, 4, 5. Okay? And that's going to give us our sample mean. So take a second and calculate that. And that value that you're getting should be 117 over 5, which will give you, sorry about that, which will give you an approximate value of 23.4 chips. We'll talk about in a minute how we do the rounding for mean, median, and mode. I've got that on another slide here in just a second, okay? That's how we find the mean. Now, obviously, if you've got a large group of numbers, then it gets a little bit more tedious as far as adding all those numbers together. Sometimes you may want to use something like StatCrunch to be able to do that a little bit easier and a little bit more effectively. All right, let's take a look at the next measure of center, which is the median. Hang on a second, I'll get this scooted down where y'all can see it. All right, so the median of a data set is the measure of center, that is the middle value, when the original data values are arranged in order of increasing or decreasing magnitude. So that's one thing that makes finding the median kind of a pain. If you've got a lot of data values, you do have to write them in order. You have to sort them in order. You can do increasing or decreasing. That part doesn't matter. And if you've got Excel or if you've got something like StatCrunch, you can probably make that particular program do that for you, which makes life a lot easier for you, especially if you're working some of the homework problems and you're having to deal with those data sets that are in the back of the book. Turn StatCrunch on and let StatCrunch do these things for you, okay? It'll make it go a lot faster. All right, so calculation and notation of the median. We use an X tilde, which tilde is that weird looking little curvy thing on top of the X right there. That represents your median. Important properties of the median does not change by large amounts when we include just a few extreme values. Because if you think about it, since you're arranging them in order and then you're just finding the middle point, what happens is if you've got one really large number on one side, it doesn't really change the middle value any more than a much smaller number on that same side would. Okay, so it's very resistant to large data values. And the median does not use every single data value; it just uses a few of them. If you happen to have one data value in the center, that is your median, literally the middle value. If you do have a couple of numbers in the middle, you take the average of those two, and that's your median. Okay, let's take a look at this example here for finding the median. This is the same sample we had just a minute ago, the 5 cookies, 22, 22, 26, 24, and 23 chips. So your first step is to write all those values down in order, increasing or decreasing. So I've got 2, and then I got a second 22, and then I got a 23, a 24, and a 26. Okay, that's pretty easy to see what the middle value is going to be in this list because it's really short. So we can tell real quickly that 23 is going to be our median. Okay, in a few minutes we'll look at one or two more problems, and I'll try to find us one where we've got 2 values in the middle so you can see how that works when there's 2. Like I said, if you do have 2 values, like if this had been 6 values instead of 5, then I would add 2 values in the middle. And you just average those 2, and the average of those 2 numbers is your median. All right, mode is our third measure of center, and we'll look at an example of this in just a minute. We're just going to kind of talk about what it is right now. The mode of a data set is the value that occurs with the greatest frequency. And I'm sorry that looks kind of weird there, the way I've got it highlighted. It would not highlight all in one piece. I had to do it separately with each word for whatever reason. Anyway, the mode of the data set is the value that occurs with the greatest frequency. So if you've got 100 numbers and the number 6 is there 10 different times and no other number repeats either that same number or more than that number, then that's your mode. Okay, you can have more than one mode. If you've got, say, 6 is there 10 times and 7's there 10 times too, then that's bimodal. If 6, 7, and 22 are all there 10 times, that's called multimodal. And if it happens that you don't have any numbers that repeat, we say there's just not a mode at all. Okay, mode is not typically used just an awful lot outside of categorical data. It's not a terribly good measure of center for numerical data. It's kind of it's just one of those things that we would have to be really lucky for that to actually hit the center, even in a situation where we've got a true normal distribution. Okay, so mode's interesting to look at, but we do use it more in categorical data than we would in a situation like this. In fact, with categorical data, it's used a good bit because we can't really take the mean or find the median necessarily for categorical data because there's not generally an order associated with, say, nominal or, nominal class. Ordinal would have an order, and we could do a median there, but nominal would not, and so that's what makes mode very useful for those situations. All right, mid-range is our last one. Now, mid-range we don't use a lot either, okay? It is really easy to use, which makes it a good measure of center in that respect. It's a very fast measure of center to find. It does help reinforce that there's several different ways that we can define the center of a data set. And one thing you have to be careful of is the mid-range is often misinterpreted as the median, which it is not, okay? It's the midpoint of the data, because what we do to find it is we take that maximum data value plus the minimum data value, and then we divide by 2. So it does actually give you the midpoint of the range, which is why it's called mid-range. But remember, median are actual data points, and so that is not the same thing as literally finding the midpoint. In fact, the mid-range may actually, not even be a possible value for your data points. You could get something like, maybe all your data points are in whole numbers and your mid-range is 26.5 or something like that. So that can happen. Of course, it happens with the median sometimes too when we have to calculate it with the 2 center data values. All right, so mid-range is easy to calculate, and we'll take a look at mid-range and mode here in just a second when we pop up a couple of those examples, which I think may be coming up next. Yeah, here we go. All right, now you'll notice in the homework that not only are you finding mean, median, mode, mid-range, but you're also answering questions about them. That's one thing about this book is most scientific, well, maybe not scientific, but most graphing calculators and lots of computer programs will help you out and find mean, median, and mode, mid-range even for your data sets. The important thing is that you understand what they're used for. Why aren't we taking a mean? What is it telling us? Is it useful in this particular situation? So let's take a look at this problem right here, and the instructions that were on this whole set of problems were to find the mean, median, mode, and mid-range, and then answer the question that's presented to us. So let's look at doing that. We need to find the mean first. So what I want you to do is take a second and just add all those up together, and then divide it by the number of numbers and see what you get for this particular mean. Okay, did you get it? If you add all of those up and then divide by the number of numbers that we've got, which is 14, okay, what you're going to see is a mean value of 16.4. And if you've read the question closely enough, these are in millions of dollars. Okay, it says listed below the gross amounts in millions of dollars. So $16.4 million is your mean. Okay, now I want you to take a look at it, list all those numbers out in order, and then find your median. Okay, we got all yours listed out. I went in decreasing order this time. So let's see what we get when we start crossing these out and find that middle point, okay? We've got an even number of numbers, so what's going to happen is we are going to get two middle points. So let's see where they are. 58 and 4, 29 and 4, 27 and 7, 22 and 8, 21 and 9, 11 and 9. Okay, so here's our two numbers that are in the middle of that list. And we got kind of lucky here because I don't actually have to do 10 plus 10 divided by 2. Since both numbers in the middle are the same value, our median is that number. So let me scoot up just a little bit and we'll do our median there. Oops. So $10 million. It's pretty easy to tell from here when we've got it listed out like that what our mode is. So take a second and look down through there and see what you would call the mode. I've got a few of them marked out, but let's take a look. How many times, or that's not really a good way to ask it, I don't guess. What's the highest frequency of any one particular value on the list? Well, we've got a couple of different ones, don't we, here? The 10s are there twice. I've got 2 9s. I've also got 2 4s, okay? Nothing else is listed any more times than that, so that's my highest frequency, 2. So that means I've got actually 3 modes. It's multimodal, okay? So 10 million, I'm going to abbreviate a little bit. 9 million is a mode also. And then 4 million as well. Okay? So we've got 3 different modes. Now we're going to find the mid-range. So let's scoot up even a little bit more. All right, so to do the mid-range, we've got to go back and we have to find the largest and the smallest, which is 58 and 4. That's the maximum value and the minimum value. So 58 minus 4 divided by 2, okay? Don't confuse this with the mean. You're just doing largest minus smallest. I'm sorry, largest plus smallest, excuse me, divided by 2. So if we add those two together, I'm going to have 62 divided by 2, and that's going to give me 31 million. So that's our last measure of center on this group, okay? So that's the difference in the 4 different measures of center. Now let's go back up and have a look at that question that it asks us. And the question's actually Well, the first question's about the measures of center, the second one's not. What important feature of the data is not revealed through the different measures of center? Now, this one might be a little tricky at first to think about, okay? Because you look at that data and you think, well, what is it that we're not seeing? But remember what it is we're looking at. We're looking at different box office receipts for the first 14 days that this very popular movie was released, okay? And so what we're not seeing here is a relationship between the data and the time, between the amounts and the days in which they were collected. Now, you do see that when you see the lineup of values there. And so you could very easily do a time series graph based on that data. It even comes in the right order for you immediately, but just looking at the measures of center themselves, we don't see that time relationship at all. Measures of center are more of a summary type bit of information. So we call that a summary statistic. So it condenses the values that we have down to a single value. All right, the second question is, what is an explanation for the fact that the three highest amounts are the first, third, and fourth values listed? So I want you to really think about what this thing is telling you. It says the movie opens on a Wednesday, and then the amounts are listed in order for the first 14 days of the movie's release. So because of that, why do you think that you see your highest values here, here, and here, okay? So stop the video for a second and think about that. All right, the reason why we're seeing those three high values there specifically, the 58, of course, is the first day of the release, okay? So that's why that's a high value, in fact, the highest out of the whole group. You know that there were lots of Harry Potter fans out there who were just waiting for that very first day that it was released to go see it. Then you see a little drop and then another little pickup right here with these 2 days. That's because we have a Wednesday, Thursday, and then a Friday and Saturday for these two. Okay, so that's the first weekend of the release. Even that Sunday is pretty high as well. Then you see a huge drop from the 21 down to the 10 when we cross over into the Monday of the next week. But if you're looking, you've got Monday, Tuesday, Wednesday, Thursday, and then another small peak right here with the Friday, Saturday, and Sunday, that next weekend out. Okay, so that's why we're seeing some higher numbers in those particular places, and it's a good thing when you've got data sets to sort of look and see what you can determine from the data that you're actually given. All right, let's scoot on to the next page. Okay, now this question is about phenotypes of peas. Biologists conducted experiments to determine whether a deficiency of carbon dioxide in the soil affects the phenotype of peas. Listed below are the phenotype codes, where 1 is equal to a smooth yellow, 2 is a smooth green, 3 is a wrinkled yellow, and 4 is a wrinkled green. Can the measures of center be obtained for these values, and do the results make sense? Well, as you can see here, all of the values are numerical. So any of the calculations that we've talked about can be done on those values. It's not like we're trying to take the mean of a bunch of categories, okay? We have numerical values for them. But think about whether or not they should be used, okay? Do they make sense? If I take the means of all these numbers, what's that going to tell me? It's a measure of center, but in truth, those numbers, 1, 2, 3, and 4, are not even ordinal data. They are categorical or nominal data. They are replacements for the names. Okay, there's no order that makes sense. Differences don't tell us a single thing. I mean, how can you really rate the difference between a smooth yellow and a smooth green, numerically speaking? Intervals, so, interval data is out, and the ratios won't make any sense either. We could find the mode, okay? The mode would tell us something if we take a look at the mode, and it looks like it's probably 1, just by looking at the numbers. I hadn't counted them up, but let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I believe we have 11 ones. That's certainly more than any of the other values. And so what that tells us is that we have mostly smooth yellow. That is our mode for this particular group. So our mode is equal to 1, or if you want to put it in words, you can, smooth yellow, because like I said, the 1 is really just a label. just a representation of this category. Okay, so the mode would make sense for us, but mid-range doesn't make any sense because we know that the range is going to be 1 through 4. Median won't really tell us anything. We could certainly put them in numerical order, but like I was saying, the order really doesn't make any sense for this particular set of data. So median's useless, mean is useless, mode is the only one of the measures of center that could do anything for us. All right, let's take a look at our next problem. All right, political contributions. Listed below are contributions in dollars made to the 2 presidential candidates in a recent election. All contributions are from the same zip code as the author, and the data are from the Huffington Post. Do the contributions appear to favor either candidate? What do you conclude after learning that there were 66 contributions to Obama and 20 contributions to McCain? So we have kind of two different questions there. The first is, do the contributions appear to favor either candidate? Well, if you're just looking at the numbers kind of scattered around as they are here, you can't really tell much about them. You'd be doing much better if you would take an average of the two, not an average, but a mean of the two. Maybe look at the median as well. Mode probably wouldn't do much for you here, but the median and the mean might show you something interesting. So let's maybe take a look at the mean. Okay, hopefully you took a break and figured out the mean and median for each one. If you didn't do that, go ahead and take a quick little break and calculate those values before we talk about them. If you count the values for each, there are 15 different numbers in each person's group, okay? So we got 15 contributions for Obama, 15 for McCain. So obviously there were some random selection methods applied here to pick 15 out of the 66 contributions for Obama and the 20 contributions for McCain. When we take a look at the averages or the means for each one, Obama's is $653.9 and $653.90, I should say, and McCain's average is $458.50. And then we've got medians of $452 for Obama and $350 for McCain. And if you look up there at the values, they appear to all be whole number values. We don't have any cents or anything like that in the values that are given in the problem. So all of those values were obviously either whole numbers to begin with, or they were rounded to the nearest whole. And I realized when I took a little break to calculate these two values for you guys that we hadn't talked about the round off rule yet. So we will talk about that here in just a second when we get done with this. I thought that I had put that on a slide, and it may pop up here in a minute when we get past these problems. I just don't remember where it was when I put the slides together. So anyway, we'll go ahead and talk about it now just in case I don't have it in here at all. All right. So do the contributions appear to favor either candidate? Well, it does appear that Obama gets a larger average contribution than McCain does. But the second question may be even a little bit more telling about this particular zip code. What do you conclude after learning that there were 66 contributions to Obama and 20 contributions to McCain? Well, obviously we had more people doing the contributions for Obama. So, judging by the average contribution to Obama and the total number of contributions that would have been in the population, if we'd looked at the complete population of donors from this particular zip code, it appears that the people in this zip code do favor Obama, perhaps more Democrats than Republicans, or maybe you just had more Democrats and independents who favored Obama at the time. All right. So let's take a look at what the round-off rule is. Let me just scoot down on this page just a little bit. The round-off rule eliminates the need to designate a particular value to round to every single time we have a mean, median, or mode problem. For the mean, median, and mid-range, what you do is you round 1 decimal place farther than the data. And that's what we saw in this problem here. The mean and median, we didn't do the mid-range on this one. We could have, but we didn't. The mean and median were both rounded to the nearest tenth, even though the data places were all to the nearest whole dollar, okay? And sometimes when you're working with dollars, you may see them rounded off to the nearest cent. That is one thing that you'll notice occasionally, but for the majority of times, and if the problem doesn't really say anything about what to round off to, you can use this rule instead, okay? So just remember to round off one decimal place farther than the data points that you were given. The mode, it's not necessary to round the mode, okay? Because after all, we are picking a number out of the series, okay? It's not like the median where if you have two of them, you have to take an average. With the mode, you know exactly what you're going to get, and it's going to be one of the data points. So there is no need to round the mode. You just keep it with the same data place as the data points that you draw it from. Okay? All right, let's see what comes up next. Okay, two new types of means here. Finding the mean from a frequency table is the first one we're going to take a look at, and then we'll look at finding the weighted mean. The mean from a frequency table is done when maybe you don't have all of the data points. Maybe you just know the frequency distribution or the frequency table. You can still get a fairly accurate mean from that table, okay? So what we're going to do, we're going to apply this formula to this table you see down towards the bottom of the screen. Yeah, what you have to do is do the sum of the frequency of each class times that class's midpoint. That's that f times x that you see right here on top, the sum of f times x. And then you do that over the sum of the frequencies. So you'll have to find the class midpoint of each class, and then you'll have to multiply that class midpoint times the frequency. So that's what we're going to do down here in just a second, okay? Pretty easy formula to do. You just have to memorize, you just have to kind of remember what the f and the x represent. So f is the frequency, and x is the class midpoint. And I'm sorry, when I write with this stylus, it looks so bad. It's probably has a little bit to do with the angle that I'm writing this at. I've got the iPad propped up a little bit while I'm writing to try to make it a little easier to write and not to get my wrist in the way, but it's making me write funny. All right, so anyway, let's look down here at this problem and see if we can use that little formula to figure out what our mean is. It's not a perfect mean, and it's not going to be the exact same as the mean that you would get if you actually took every data point, but it is a easy mean to use. If you've got an awful lot of data points, this is sometimes preferable to trying to type all of those data points in, unless they happen to already be in a table that you can use to find the mean from. And sometimes you just don't know the data points. Sometimes this is all you have, okay? So that's what we're looking at now. This is all we have. We don't have the data points. We just have the frequency distribution. So for this particular problem, we're going to compare what we get for the frequency table mean with the actual mean. Ooh, and that doesn't look nearly as good as I'd hoped that it would. Let me see if I can back off and just get rid of that. Yeah, that highlighter didn't work out like I want it to. It says up here in the instructions, y'all can read them, they're kind of tiny, that exercise 29, which is this one right here, should give you an actual mean of 35.9 years, okay? So what we're going to do is take the mean from the frequency table and just kind of compare it to that, see how we do with that mean, okay? So what we're looking at is the age of Best Actress when that Oscar was won, okay? And our classes are all over here, and then our frequencies are here. So let's kind of add on to our table. And what I'm going to do is I'm going to make a column right here that's going to give me that class midpoint for each one. And then in the next column, what we'll do is we'll write down the frequency times that class midpoint. If I have enough room, as big as I'm writing, we may have to make it a little bit longer. Okay? All right, so let's find our class midpoints for each one. Okay, so what we would do is 20 plus 29 divided by 2. And you're going to find that that's equal to 24.5. And then our next one is the midpoint of 30 to 39. And as you can probably tell, that's going to be 34.5. And we can just kind of use that same pattern on down. You don't have to keep calculating it if you can figure out from the first one or two what the rest of them are going to be. That works out nicely when you've got a class width of 10 like we do here. 64.5, 74.5, I'm going to need one more. Down here, 84.5. Okay. So now what we need to do is multiply each one of those by the frequency. Okay, if you didn't give yourself a second to go through that, go ahead and stop the video and go through each one of those and do the frequency times the x value on each one. We get a 661.5 on the first group, a 1,173 on the second, 578.5 on your third class, 109 on your fourth, 258 on the fifth, and the last two have a frequency of 1, so 74.5 and 84.5 is what you have there. Okay. Now remember in the formula, what you have, let me scoot down to have us a place to write it here. Our mean is going to be the sum of what we just calculated there over the sum of the frequencies. Okay, so what we need to do is sum up all of the frequencies and sum up the column where we've got frequency times x. So let's take just a second and do that. Stop the video and do those two sums for me. Okay, so our sums that we found, the sum of the frequencies is 82, and the sum of f times x is 2,939. And now what we need to do is put those two together in our fraction and calculate that division. Okay, so we're going to have 2,939 on top, 82 on the bottom. See if you can remember our round off rule. Since our data points, actually we don't have much of data points, do we? What we have to go on is the class midpoints. So what we have to do is just follow what the class midpoints are rounded to, which is the nearest tenth. Okay, so let's take a break and do that calculation. All right, so the number I got when I did it on the calculator was 34.988 and a few more numbers. So when we round that is going to round up to 35. And if we want to be real sticklers about needing the 10th value, we can put a 0.0 at the end there. Okay, so this is the age that we're looking at. 35 years is the mean from the frequency distribution. And if we go back up here and compare what it says, 35.9 was the actual mean for this particular set of data. So we're not too terribly far off. We're about a year down from that mean, but it's close. It's not super close, but it is pretty close. And you can go by that. And we use it in a lot of cases. Like I said, it's a lot faster to find, a lot easier to find if you've got a lot of data points. And sometimes you just don't have a choice because you just don't have the rest of the data. All right, let's do the next type of problem. This is a weighted mean. Okay, weighted means are used in a lot of cases, like with grade point averages, grading scales, like what we do in our class. So what we do is we do the mean by taking the weight of each data point times the data point. That's what you see up in the numerator here, okay? And then we divide that by the sum of the weights. Now, the weights won't change, okay? For example, like if it's GPA, your weights are your credit hours per class, and then your X value that you're going to have is how many quality points you get for that particular class. And the quality points are given based on what grade you receive in that particular class, like an A, B, C, or D, okay? So let's take a look at this problem that's done down here. It's a very similar setup to what we have with the frequency table. It's just that we don't have to do the class midpoint. We have actual point values for x. All right, so let's scoot down just a little bit. Okay, and I'm going to kind of list this out. We know that she's got, let's do it this way. The weights are our credits, okay? So she's got one class with a 3 credit, and that class she received an A in. Her next class, oh, and I didn't even read it. It says in her first semester of college, a student, the author, took 5 courses. Her final grades, along with the number of credits for each course, were A with 3 credits, A with 4, which is what I was going to do next, a B with 3 credits, a C with 3 credits, and an F with 1 credit. I don't have quite enough room, so I'll scoot down just a little bit. 1 credit F. And the quality points, which are going to be our X's, are assigned as to the letter grades as follows. A is equal to 4, so she gets 4 credits for that one. 4 quality points for that one. A B is equal to 3, and we'll have another 4 right there, and that'll be a 3. A C is 2. She's got one of those. She doesn't have any D's, but she does have an F, which is 0. Okay, so what we're going to do then is find the product of W times X. Then we'll add up all of our W's, and we'll add up all of those products, and that'll be what we'll use in our formula. So if we multiply straight across, 3 times 4 gives me 12. Okay, so she gets 12 for that particular class. 4 times 4 is 16. 3 times 3 is 9. 3 times 2 is 6. 1 times 0 is 0. All right. So those are the total quality points for each one of those classes. And what we need to do now is sum those 2 rows, those 2 columns up. So take a second and do those sums. Okay, so our sum of all of the weights, if you add all these credit hours up, she has 14 credit hours for that semester. And then when you add up the quality points, you get 43. I'm going to double check that one more time just to be sure I've got the right thing there. Okay, I just wanted to double check to make sure I hadn't made a careless error because I did do it in my head the first time, so I just wanted to make sure I had the right thing. Okay, so now we take those 2 values and we're going to plug them into that formula that we got earlier. So our weighted mean is equal to the sum of the weights times the points over the sum of the weights. Okay, so what we've got is 43 over 14. And we're going to go ahead, and since all of our numbers are in whole number form, we don't have any decimals for anything, we'll round to 1 decimal place. I tell you what, we'll go ahead and do 2, because most colleges use 2 decimal points in their calculations for GPA. This is another one of those situations where it's a little different than the normal round-off rule. So we will go ahead and do 2 here. But in generally speaking, if you're not told what to go to, you just go ahead and do just to 1 decimal place, okay? So take a second, calculate that, that division, okay? And you should get approximately 3.07 for the GPA there, okay? Like I said, we did go 1 more decimal place than the round-off rule suggests, but that's just because I know that typically GPAs are calculated with 2 decimal places instead of just the 1, okay? All right. So that's going to finish it up for us. I was going to go ahead and do a little stat crunch demonstration for you, but I think that may take more time than we've got. I might try to squeeze it in right quick, though. Let me see if I can get it done. If this crashes and burns, I'll edit it off, maybe. Okay, so let me see if this will work like it's supposed to. Okay, well, I tried to get it pulled up, and you may be able to see that I'm almost in there, but it keeps telling me that I can't sign into it for some reason, so I think it's because it's pulling from the browser from inside this particular app. So I'm going to have to go see if I can't figure out how to fix that, but because I think that it would be something that would be good to be able to add the videos. Anyway, it won't let me log in, but what you'll do, if you want to use the StatCrunch, if you look across the top, when you log into StatCrunch from your MyStatLab, there will be a little button at the top that says Stat, And so what you'll do is either pull up a data set like I have here, or you can type your own data in a column, and you click on the stat button, and then you pick summary stats, and the little dialog box will open up, and you'll have to tell it what column you want it to pull the values from, which if you've typed them in yourself, there'll probably only be one column there anyway. And then you'll also need to tell it what statistics you want, and you'll be able to do a whole lot of stuff, like you can get it to tell you how many sample values there are, which is your n value. You can get it to do mean, median, and mode, but all, I think, and I think you can do mid-range too. And then later, as we progress on through chapter 3, there's some other stuff it'll do too within that same summary stats. But you can click all the ones you want in one little box, and then click compute, and it'll pull up a box that'll have all that data in it that you're interested in finding. Okay, so that's sort of in a nutshell. I'm sorry I can't actually show it to you because I thought that was going to be really cool, but it won't let me do it. So anyway, y'all can give that a try and ask me about it in class if you need to. All right, so that's it. So I'm going to try to get this thing uploaded to YouTube right quick and get it out there to y'all. I'll talk to y'all later.